All right, hello and welcome. This video is going to quickly cover the remainder theorem. All right, so let's just jump right into what is the remainder theorem. So what the remainder theorem tells us is that if you are dividing some polynomial, which we'll just call f of x, if you're dividing that polynomial by x minus k, so like for example, x plus 2, x minus 3. So if you're dividing that polynomial by x minus k, the remainder that you would get is the same as the value of f of k. All right, it's going to be the same as the value of f of k, and we'll see this in action in a second. All right, so let's see it in action. All right, let's see what exactly am I talking about. So here we have this function, and we'll do a couple of different examples with this same function. We have this function f of x is equal to 4x cubed minus 6x squared plus 8. All right, and we're just going to start off by doing this division. We're going to divide f of x by x plus 1. So of course, could we do polynomial long division? Yes, but remember that synthetic division is a little bit quicker, and this is an x to the first power, so we can definitely go ahead and just use synthetic division. So I'll put negative 1 up in my upper left-hand corner. Then I have 4, negative 6. I need that 0 placeholder, and then 8. I'll draw a line down. So I bring down the 4. 4 times negative 1 is negative 4. Negative 6 plus negative 4 is negative 10. Negative 10 times negative 1 is 10. 0 plus 10 is 10. 10 times negative 1 is negative 10. And then 8 plus negative 10 gives me a negative 2. All right, so I could write this out and say, well, that's 4x squared minus 10x plus 10 plus a negative 2 over x plus 1. All right, and what the remainder theorem tells us is that this value right here, this negative 2 value that we see, well, that's going to be the same exact value as if I were to evaluate f of negative 1. So if I were to take negative 1 and plug it in to this equation up here. So let's just check and see that that works. Negative 1 cubed is negative 1, so that first term would be a negative 4. Then minus 6x squared, well, negative 1 squared is positive 1, so that's going to be minus 6. And then plus 8. Well, that's negative 10 plus 8, which gives me a negative 2. So look at how those values line up. All right, let's just do one more example with this. Let's say that we're dividing it by x minus 2. All right, we're going to divide this by x minus 2. X minus 2. So I'm putting a 2 in the upper left-hand corner. I go 4, negative 6, 0, 8. Bring down the 4. 4 times 2 is 8. Negative 6 plus 8 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. 8 plus 8 is 16. So again, I'm saying this value of 16 is going to be the same as if I did f of 2 now. All right, I want to do f of 2 because when you're dividing by x minus k, that's the same. The remainder is the same as if you evaluated f of k. All right, so here I'll plug in 4 times 2 cubed minus 6 times 2 squared plus 8. 2 cubed is 8, so that gives me 32. Minus 6 times 4 is 24, plus 8. 32 minus 24 is 8, plus 8 is 16. All right, so we can see that this remainder theorem works. All right, this remainder theorem definitely works. And let's talk about, now, why is this important? Like, why would we ever really care about the remainder theorem? Well, our goal, right, the whole purpose of why we're dividing polynomials is to be able to factor polynomials of a higher degree. So like if you had this polynomial, right, we want to be able to factor this. So what we need to do is find values So find some value k for which f of k is equal to 0. Because if f of k is equal to 0, then we could divide f of x by that factor x minus k, and we know that we'll get a remainder of 0. All right, so we are going to see that happen in the next video. Thanks for watching. Hope this helps.